Writing Rules Part 2. This time we're going to talk about writing rules by looking at function tables. So we're going to continue the exploration of the connection between input-output tables, patterns, and functions. Patterns are functions and they are predictable. So you can write rules because you can predict what will be the next value. Okay. There are 5 different patterns. First, you have number sequences, numbers in tables, geometric figures, linear graphs, and numbers in real-life situations. So you can see patterns in these 5 scenarios. You can also see patterns in nature, and we're going to discuss that in a different lesson. Let's start with number sequences. We actually started our unit by looking at number sequences. And so this is going to be a review, and so you know that number sequences is part of patterns. Okay, let's name some sequences. Okay, we're not, it's part of saying or writing the rules. Okay, given the sequence 2, 4, 6, 8, 10, if we want to name the sequence, we'd say they are even numbers or multiples of 2. Okay. If you're writing rules, you'd say add by 2 or plus 2. Okay. Another set of numbers, 1, 3, 5, 7, 9. If we name the sequence, they are odd numbers. Okay. You also have 3, 6, 9, 12, 15. These are, okay, guess what do you call this? You're correct. They are multiples of 3. Okay, let's continue. Another sequence, 5, 10, 15, 20, 25. Yes, they are multiples of 5. Okay, the last sequence, 1, 4, 9, 16, 25. Any guess? Does anyone know what this sequence are or is? They are a set of square numbers. Square numbers because 1 is 1 times 1, 4 is 2 times 2, 9 is 3 times 3, 16 is 4 times 4, 25 is 5 times 5. If we continue the series, it's going to be 6 times 6. The next number will be 36. And the next one is 49. Okay, you call that square numbers. Okay. Again, to continue number sequence, given the sequence 2, 7, 12, 17, 22, 27, 32, 37. If you look at it, each sequence, you add 5. Okay, so we can describe this number sequence as they are in ascending sequence, so it's in increasing sequence by equal steps, and you add 5 each time. Another number sequence, 1/10, 2/10, 4/10, 8/10, 1 and 6/10, 3 and 2/10, 6 and 4/10. If you take a closer look at it, it's times 2 each time. So we can describe this number sequence as, again, ascending sequence or an increasing sequence, but by unequal steps. So you describe it as it starts at 1/10 and you double it each time. The last number sequence. Let's describe what's the rule for 100, 99, 97, 94, 90, 85, 79, 72. That's minus 1, minus 2, minus 3, minus 4, and so on and so forth. Okay, think of how you're going to describe this pattern. Okay, that's correct. This is a descending sequence. That means it's a decreasing sequence, and it's decreasing by unequal steps. So you can describe by saying starts at 100, and then as you go along, you are subtracting by 1, 2, 3, and then you can put the 3 dots to say so on and so forth. Okay, now let's move on to the next type of patterns, and that's numbers in tables. Now, we call this table input-output table. We can also call this table as function table. Okay. For every function table or number in table or input-output table, there's an X and there's Y, and Y is always going to be the output. Now, it doesn't have to be X and it doesn't have to be Y. You can use different variables, but for X and Y, it's easier to graph them. Okay, because you have your X will be graphed at the X-axis and Y along the Y-axis. Okay, but we'll be talking graphing later on. Okay, so based on the pattern in the input-output table below, what is the value of Y when X is equal to 4? So let's put some of the values for Y so that we will see the pattern. When X is 1, your Y is 7. When X is 2, your Y is 14. And when your X is 3, your Y is 21. At this point, we say what will be the value of Y when X is 4. For some of you, probably you already know what's the number in here. Okay, now, I'm going to give you some rules that you can use, but this is what you can do most of the time. It doesn't mean that this will work every time, but most of the time this will work and it will help you structure your thinking. First one is make a table. Second, find the constant difference. Third, multiply the constant difference by the term number X. Number 4, add or subtract some number in order to get Y. Check your rule for at least 3 values of X. If you're writing down notes, it's best that you write this in your notebook. Okay, let's use these rules for the table that was given to you a while ago. Okay, we'll have that same table again, and let's do this. Okay, first one, it says make a table. We already have a table, so we go to the second step, which is find the constant difference. So we look at the number here at the the output, and see how much is the difference. So from 7 to 14, there's a difference of 7. And from 14 to 21, you again have a difference of 7. Okay, so we know that there's a difference of 7. Let's take a look at number 3. Okay, number 3, sorry, this is not 0, but this is number 3. Multiply the constant difference, that will be constant is 7, by the term X. So we multiply 7 to X. So 7 times 1, 7 times 2, 7 times 3. Okay, so let's do that and write it as part of the rule. So 7 and X, you write that as 7X. Now, let's move to step 4 because we're done with the third step. It says, add or subtract some number in order to get Y. If we do the multiplication, 7 times 1, you will have 7. 7 times 2, you will have 14. And 7 times 3, you will have 29. We don't really need to add nor subtract any number. So we could do plus 0 or minus 0 because we already get the Y value that we are looking for. Okay, now let's move on to number 5. Check your rule for at least 3 values of X. We already did that. We check for 1, 2, and 3 and it works every time. Okay, So this is our last step, and we are just going to continue in simplifying our rule. So 7x plus 0 should equal to y, okay? And to simplify this is the same as y is equal to 7x. I do not need to write plus 0 because it's not going to do or change the result. Okay, so if we continue, 7 times 4 is going to give you 28. Okay, now here's a new one. Uh, we already put the value of 7, but what I would like you to do is find the rule and write it. Stop the video, pause the video, and do it yourself. Follow the rules that I have given you and write the necessary rules or function. Okay, let's check your work. Let's see if you have found the right rule or function for this table, input-output table. Should be y is equal to x plus 3. Okay, if we take a look at the difference between 5 and 4 is 1, 6 and 5 is 1, 7 and 6 is 1. So, you could actually write 1 here beside the x. But you don't have to because the default is if you don't see a number beside x, the default is there's a 1 beside x. So this is actually 1x. Okay. If we go and follow the rule, 1 times 1 is 1, plus 3 is 4. That's correct. 2 times 1 is 2, plus 3 is 5. 3 times 1 is 3, plus 3 is 6. 4 times 1 is 4, plus 3 is 7. So your rule is y is equal to x plus 3. Okay. Now, go and find your textbook and solve number 6, all of the questions under number 6 on page 221 to check your understanding. It will ask you to write down the rules or function of the table given to you. Okay, let's continue with geometric figures. Okay, given geometric figures, you have step 1, step 2, step 3, step 4. Okay, we're going to follow the rules that I have given you. The best way is to make a table. Now, when you make a table, step 1 will be your x. The number with the step is your x. So 1, 2, 3, 4 are your x values. Okay, here you are. And then y will be the number of squares. So for step 1, when x is 1, you have 1, 2, 3, 4, 5, 6, 7 squares. When you are in step 2, you will have 1, 2, 3, 4, 5, 6. 6 times 2 is 12. You have 13. Okay. In step 3, x is 3. You have 19. And then I did not include step 4. In your input-output table, please include step 4. So complete the table. What could be the rule for this? Okay, stop the video and work on finding the rule or function for this input-output table. Okay, it should be y is equal to 6x plus 1. Okay, another geometric figure to test your understanding. Here you go. And then all the figure numbers, 1, 2, 3, complete this table again. So we're missing figure 4, that should be 20 tiles. Use the rules again and find out what is the rule or function for these geometric figures. Okay, let's see if you're correct. It should be y is equal to 4x plus 4. Remember that it's not always plus 4. It could be minus or subtraction. So you have to be careful. Always check your rule for at least 3 values of x. Okay, now to check your understanding, solve number 5, 6, 7 on pages 226 and 227.